Hello. So in this class we'll discuss cam profile with flat face follower. Okay, having uniform acceleration and retardation motion. So just look at the problem statement. What we have: a cam drives a flat reciprocating follower in following manner. During first 120 rotation of cam, the follower moves outward through distance of 20 mm with uniform acceleration and retardation. Okay, followed dwells for next 30-degree rotation, and again for next 120 rotation. It has uniform acceleration and retardation. The follower dwells for the next 90 rotation, and the follower, the minimum radius of cam is given 25, and we have to draw the cam profile for this arrangement. Okay. Now what we have this arrangement of uniform acceleration and retardations where we are plotting the displacement diagram. Now lift of follower is available. Just look at the arrangement. So what is the lift? This lift of follower is given. So that lift is again 20 mm. Just look at the data. Angle of rotations are available. Angles are 120 degree. So this angle is 120 degree. It is first angle. They have mentioned dual is given 30 degree. Okay. So we can write dual 30. Again, 120 degree angle of return is available. Okay. So these are the angles which we have for this follower motion. 120. Then we can write 30. Okay. And this is again 120. Okay, so again to create displacement diagram, we have some scale. You can take scale 1 centimeter is equal to 20 degree. That is the suitable scale for this arrangement. So what we have, each part will be of 6 centimeter. This is 6 centimeter. Second part is 1.5 centimeter, and third is again 6 centimeter. So you can draw a line. Okay, so we can divide 120 degree into 6 parts. Again, remaining 120 degree into 6 equal parts. Okay. Now, after dividing all these cam rotations, okay, cam angles, what we have to do, we have to first draw a diagonal line. So simply we can create a diagonal line. Okay, okay. Then what we have, this distance is 20. So upper part we can divide into 10 mm. Upper part is 10 mm. Lower part we have 10 mm. Okay. Line number 3 as a reference line we can take. Divide that 10 mm into 3 equal parts. So each division we have 3 mm, 3 mm, 3 mm. Okay. Again, this is 3 mm, 3 mm. Connect lower divisional points to lower diagonal, upper divisional points to upper diagonal. So we have first inclined line. Okay. First vertical line. We have second inclined line, second vertical line. Third is the diagonal point. Fourth inclined line, fourth vertical line. Fifth inclined line, fifth vertical line. So what we are getting the points. Okay. We are getting points for this line. Okay. So first point is this. Then we have second point. Then we have third point. Then we have fourth point. We have fifth point, and this is the closing point. So by connecting all these points, okay, with curve, we are having uniform acceleration and retardation diagram. Okay. Similarly, towards right side, again, this line we have 6 divisional points. Okay. This part is of 6 centimeter. So we can take line number 3 dash as a reference line. And this distance is again 10 mm per distance. Lower distance is again available 10 mm. Divide that per part into 3 equal division, 3 mm, 3 mm, 3 mm. Lower part into 3 equal division, 3 mm, 3 mm, 3 mm. Okay. Connect upper divisional points to upper diagonal, upper corner, lower divisional points to lower corner. Okay. And simply connect this. Then again we have first incline, first vertical, second incline, second vertical, third as it is, fourth incline, fourth vertical, fifth incline, fifth vertical. And by simply passing all these points, okay, we are getting this freehand curve. Okay. So this is all about, we have to create that displacement diagram with the help of this cam rotation and lift up. Okay. Now second part is, just 1 minute. Okay. Second part is we have to draw the flat face follower with that arrangement. Okay. Now to create flat face follower, what we have is angles are 120, 30, 120. Okay. So simply you can take that angle. Okay. So draw divide that 120 into 6 parts. 30 as it is again, next 120 into 6 parts. Okay. So just locate that distances. Okay. So we have this displacement values. Okay. So we have displacement value 1b. So just locate the displacement value 1b. Just take this displacement value. Okay. 1 beam compass. Just take 1 beam compass and cut that displacement value on line number 1. Take 2c distance in compass. Above that, place circle and just cut that 2c value. 3c distance in compass. Sorry, 3d distance in compass. Then cut that value. This is point number D. Okay. Then 4e distance, 5f, 6g, 7h, 8j, then k, l, m, and p. So for all these locations, we are marking the values. So this point is 0 dash. They have taken 1 dash. Okay. Then 2 dash, 3 dash, 4 dash. Then we have 5 dash. And this point is 6 dash. For all these locations, we are marking the points. Okay. Now, once we have all these points, then as we discuss this, we are supposed to say line number 1. Okay. This is tangential line 4.1. Suppose say 4.2. Okay. 4.2. Suppose say this is the tangential line. Okay. These two tangential line must cut to each other. Again, 4.3. Suppose say we have one more tangential line. Okay, so below that tangential lines you need to create the curve. So your curve must pass through before that tangential line and after that tangential line. So this is the orientation of your curve. Okay, so by intersecting all these points, that is 4.1 to 2 we have one curve, 4.2 to 3 we have second curve, 4.2 to 3 to 4, 4 to 5, 6 to 7. So we are basically getting intersecting points here. Okay, and below that intersecting points we are passing the curves. So we have all these intersecting points if you look at this arrangement. Okay, so by considering the data of details of all this, okay, so your curve must pass through that tangential points where we are having intersecting lines like this. These are the intersecting lines. These are the intersecting lines. Just look at the part, and we are targeting curve that will pass through that intersecting line, which will not go beyond the intersecting lines. Okay, simply by tracing all the points inside that intersecting lines, we'll get that freehand curve. Okay, so this is the cam contour which we can trace with the help of this uniform acceleration and retardation. Okay, so with the help of acceleration and retardation, by connecting all these points, and trace cam contour. So this is all about flat face follower with uniform acceleration and retardation diagram. Thank you all.